Hello friends, welcome to our YouTube channel. Today we shall solve a couple of numerical problems on DC transients in series RC circuits. Today we shall learn how to find different parameters when a series RC circuit gets suddenly connected to a DC source. Problem number 1. A capacitor is charged by a DC source through a resistor of 1 mega ohm. If in 1 second the voltage across the capacitor reaches 80% of its final value, we have to calculate the value of the capacitance. Let us first jot down the data given. Resistance R equals to 1 mega ohm. Let the value of supply voltage be V. After 1 second, the value of capacitor voltage reaches 80% of V, that is Vc at t equals to 1 second equals to 0.8 volt. When a capacitor charges through a resistor at any instant t, capacitor voltage Vc equals to V into 1 minus e to the power minus t by tau, where time constant tau equals to R into C. Or we can write 1 minus e to the power minus t by tau equals to Vc by V. Putting values, we get 1 minus e to the power minus 1 upon tau equals to 0.8. Therefore, time constant tau equals to 0.6213 second. That is equal to R into C. Let us now calculate the value of the capacitance. C equals to tau by R, that is equal to 0.6213 divided by 1 into 10 to the power 6, that is equal to 0.6213 into 10 to the power minus 6 farad, or 0.6213 microfarad. Problem number 2. A capacitor of 8 microfarad is connected to a DC supply through a resistance of 1 mega ohm. We have to calculate the time taken for the capacitor to reach 95% of its final charge. Let us first write down the data given. Capacitance C equals to 8 microfarad. Resistance R equals to 1 mega ohm. Let us first calculate the time constant. Tau equals to R into C, that is equal to 1 into 10 to the power 6 into 8 into 10 to the power minus 6. That gives us 8 seconds. Let the value of supply voltage be V. When a capacitor charges through a resistor at any instant t, capacitor voltage Vc equals to V into 1 minus e to the power minus t by tau, where time constant tau equals to R into C. Capacitor charge Qc equals to C into Vc. Using the expression for Vc, we get Qc equals to C into V 1 minus e to the power minus t by tau, that is equal to Q times 1 minus e to the power minus t by tau, where final value of capacitor charge Q equals to C into V. Therefore, e to the power minus t by tau equals to 1 minus qc by q, or t equals to minus tau times log of 1 minus qc by q. Time taken for the capacitor to reach 95% of its final charge t equals to minus 8 log of 1 minus 0.95, that gives us 23.9659 second. Problem number 3. A capacitor of 100 microfarad is connected in series with a resistance of 8 kilo ohm. We have to determine the time constant of the circuit. If the circuit is connected to a 100 volt DC supply, we have to determine the initial rate of rise of voltage across the capacitor, the initial charging current, the ultimate charge in the capacitor, and the ultimate energy stored in the capacitor. Let us first jot down the data given. Supply voltage V equals to 100 volts. Capacitance C equals to 100 microfarad. Resistance R equals to 8 kilo ohm. Let us first calculate the time constant. Tau equals to R into C, that is equal to 8 into 10 to the power 3 into 100 into 10 to the power minus 6, that gives us 0.8 second. The initial rate of rise of voltage across the capacitor dVc dt at t equals to 0 equals to V by tau, that is equal to 100 divided by 0.8, that gives us 125 volt per second. The initial charging current I at t equals to 0 equals to V by R, that is equal to 100 divided by 8 into 10 to the power 3, that gives us 0.0125 ampere or 12.5 milliampere. The ultimate charge in the capacitor Q equals to C into V, that is equal to 100 into 10 to the power minus 6 into 100, that gives us 0.01 coulomb. The ultimate energy stored in the capacitor E equals to 1 upon 2 CV square, that is equal to 1 upon 2 into 100 into 10 to the power minus 6 into 100 square, that gives us 0.5 joule. Problem number 4. We have to determine how long it takes after the key is closed before the total current from the supply Is reaches 25 milliampere when V equals to 10 volts, R1 equals to 500 ohm, R2 equals to 700 ohm, and C equals to 100 microfarad. Let us first list down the data given. Supply voltage V equals to 10 volts. Capacitance C equals to 100 microfarad. Resistance R1 equals to 500 ohm. Resistance R2 equals to 700 ohm. Supply current Is equals to 25 milliampere. Current flowing through the resistor R1, I1 equals to V by R1, that is equal to 10 divided by 500, that gives us 20 milliampere. Applying Kirchhoff's current law at node P, we get Is equals to I1 plus I2. Therefore, current flowing in the capacitor I2 equals to Is minus I1, that is equal to 25 minus 20, that gives us 5 milliampere. The capacitor C charges through resistor R2 at any instant t. I2 equals to V by R2 into e to the power minus t by tau, where time constant tau equals to R2 into C, that is equal to 700 into 100 into 10 to the power minus 6, that gives us 0.07 second. Putting values in the expression of current, we get 5 into 10 to the power minus 3 equals to 10 divided by 700 into e to the power minus t by 0.07. Therefore, t equals to 0.0735 second. We can conclude that the time taken by the supply current to reach 25 milliampere, t equals to 0.0735 second. Problem number 5. A resistor R and a 2 microfarad capacitor are connected in series across a 200 volt direct supply. Across the capacitor is a neon bulb that strikes at 120 volt. We have to calculate the value of R to make the lamp strike 5 seconds after the switch has been closed. If R equals to 5 mega ohm, we have to calculate the time taken by the lamp to strike. Let us first jot down the data given. Supply voltage V equals to 200 volts. Capacitance C equals to 2 microfarad. Lamp striking voltage Vn equals to 120 volts. Case 1. Lamp strikes 5 seconds after the switch has been closed. Let the resistance be R1. When a capacitor C charges through a resistor R, capacitor voltage at any instant t, Vc equals to V into 1 minus e to the power minus t by tau, where time constant tau equals to R into C. In this case, the capacitor charges to Vn through a resistor R1 at time instant t1. Therefore, Vn equals to V into 1 minus e to the power minus t1 by tau 1, where time constant tau 1 equals to R1 into C. Using values, we get 120 equals to 200 into 1 minus e to the power minus 5 by tau 1. Time constant tau 1 equals to 5.4568 seconds. Let us now calculate the value of resistance R1 equals to tau 1 by C, that is equal to 5.4568 divided by 2 into 10 to the power minus 6, that gives us 2.73 into 10 to the power 6 ohm or 2.73 mega ohm. Given supply voltage V equals to 200 volts. Capacitance C equals to 2 microfarad. Lamp striking voltage Vn equals to 120 volts. During case 2, series resistance R2 equals to 5 mega ohm. Time constant tau 2 equals to R2 into C, that is equal to 5 into 10 to the power 6 into 2 into 10 to the power minus 6, that gives us 10 seconds. When a capacitor charges through a resistor at any instant t, capacitor voltage Vc equals to V into 1 minus e to the power minus t by tau. Here the capacitor charges to Vn through a resistor R2 at instant t2. Vn equals to V into 1 minus e to the power minus t2 by tau 2, or 120 equals to 200 into 1 minus e to the power minus t2 by 10, or t2 equals to 9.163 seconds. Therefore, we can conclude that time taken by the lamp to strike T2 equals to 9.163 seconds. Problem number 6. A 50 microfarad capacitor and a 20 kilo ohm resistor are connected in series across a battery of 100 volts at instant t equals to 0. At instant t equals to 0.5 second, the voltage is suddenly increased to 150 volts. We have to find the charge on the capacitor at instant t equals to 0.75 second. Let us first write down the data given. Capacitance C equals to 50 microfarad. Resistance R equals to 20 kilo ohm. At t equals to 0, supply voltage V1 equals to 100 volts. At instant t equals to 0.5 second, increased supply voltage V2 equals to 150 volts. Given timings, intermediate time Ti equals to 0.5 second. Final time Tf equals to 0.75 second. Let us calculate the time constant of this circuit. Tau equals to R into C, that is equal to 20 into 10 to the power 3 into 50 into 10 to the power minus 6, that gives us 1 second. Change in supply voltage delta V equals to V2 minus V1, that is equal to 150 minus 100, that gives us 50 volts. Let us solve this problem using superposition theorem. Case 1. When supply voltage V1 equals to 100 volts connected for a time duration of Tf equals to 0.75 second. Capacitor voltage Vc1 equals to V1 into 1 minus e to the power minus Tf by tau. that is equal to 100 into 1 minus e to the power minus 0.75 by 1, that gives us 52.7633 volts. Case 2. When supply voltage delta V equals to 50 volts connected for a time duration of T2 equals to Tf minus Ti, that is equal to 0.75 minus 0.5, that gives us 0.25 second. Capacitor voltage Vc2 equals to delta V into 1 minus e to the power minus T2 by tau, that is equal to 50 into 1 minus e to the power minus 0.25 by 1, that is equal to 11.06 volts. Applying superposition theorem, we get capacitor voltage Vc equals to Vc1 plus Vc2, that is equal to 52.7633 plus 11.06, that gives us 63.8233 volts. Charge on the capacitor at instant t equals to 0.75 second, Q equals to C times Vc, that is equal to 50 into 10 to the power minus 6 into 63.8233, that gives us 3191.15 into 10 to the power minus 6 Coulomb. Now let us solve this problem using alternative method. Given data, capacitance C equals to 50 microfarad, resistance R equals to 20 kilo ohm. At t equals to 0, supply voltage V1 equals to 100 volts. Increased supply voltage V2 equals to 150 volts. Given time instance, intermediate time Ti equals to 0.5 second. Final time Tf equals to 0.75 second. We have calculated time constant for this circuit, tau equals to 1 second. Case 1. When supply voltage V1 equals to 100 volts connected for a time duration of Ti equals to 0.5 second. Capacitor voltage Vc1 equals to V1 into 1 minus e to the power minus Ti by tau, that is equal to 100 into 1 minus e to the power minus 0.5 by 1, that gives us 39.3469 volts. Now we shall use Vc1 as the initial value of capacitor voltage for the next part of this problem. Case 2. When supply voltage V2 equals to 150 volts connected for a time duration of T2 equals to Tf minus Ti, that is equal to 0.75 minus 0.5, that gives us 0.25 second. Capacitor voltage Vc2 equals to Vc1 plus V2 into 1 minus e to the power minus T2 by tau, that is equal to 39.3469 plus 150 into 1 minus e to the power minus 0.25 by 1, that gives us 63.8233 volts. charge on the capacitor at time instant t equals to 0.75 second, Q equals to CVC2, that is equal to 50 into 10 to the power minus 6 into 63.8233. That gives us 3191.15 into 10 to the power minus 6 coulomb. So today we have solved a couple of numerical problems on DC transients in series RC circuits. We have dealt with the numerical problems where a series RC circuit gets suddenly connected to a DC source. By step-by-step method, we have learned how to find different parameters under such transient condition. Hope this lecture has been useful for you. If you have any question or suggestion, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.